So we're back at it again, moving along here to 7.1. This video and then the homework that I'm going to attach to today's Skyward message along with this set of notes. This is just going to be what I would have you work on for the next couple of days. So the video here should be fairly short. It's just really some definitions of things that we are going to be dealing with as we go through with all the circles. I'll leave the assignment. You can kind of consider that what you would do tomorrow. So this will knock out what I have attached to this message on Skyward, those two documents. This video with those two documents should knock out the next couple of days. So take your time with it. If you have any questions, let me know. As you do the assignment, watch the video again, see if you have any questions. If you do, reach out, and I'll do what I can. So today we're just going to go over vocabulary of circles. So we'll kind of go through here, sketch some things in so we understand what it is, and should be pretty quick, pretty simple. So obviously, circle is a set of all points in a plane that is equidistant from a fixed point called the center. So pretty much all we would do here, if that's the center of our circle, then every point on our circle would be said to be equidistant from this point. So all of these lengths from the center out to the circle would be the same. Okay. And then I think we all know what that is. It's the radius. We'll get to that here in a second. Concentric circles are two or more different circles that share the same center. So if I put a center right here in the middle of the small one, it's also in the middle of the bigger one. So those basically it's circles within side of each other, and they also have to share the same center. Congruent circles are two or more circles that are congruent when their radii are congruent. So if I could somehow take this circle here, drag it on over congruent circles, this circle here, if we were to actually be able to do this, should land right on top of that circle. Same with congruent triangles. You dealt with congruent triangles last year in Math 1. It's the same with congruent circles. They basically produce each other. A chord, probably a different word now. First one where you definitely want to write this down, make a note, make sure we know what this is a segment whose endpoints are on the circle. So one way to draw a chord, put a point on the circle here, put a point anywhere else on the circle. So we could all put a point somewhere on our circle. I'm going to put mine down here. And when I connect those, notice how when I draw this line segment in, that is a segment whose endpoints, so this point and this point, are on the circle. Okay, that's a chord. Sometimes our chord is also what you are probably familiar with, your diameter. Let me move this up here, that we've dealt with before, so we'll get to that here in a minute, but our diameter would just be a chord that also goes through the center. But we've still got a segment whose endpoints, so this point and this point, are on the circle. A secant line is a line that intersects a circle at 2 points. It is an extension of a chord. So a secant line basically is going to look like a chord. It's going to intersect a circle at 2 points, but it's going to pass through. So it touches here and here. It's just those are not your endpoints. Secant line versus tangent line. A tangent line, notice how a secant line crosses twice. A tangent line is going to cross the circle exactly one time. And then this is a nice little word here to think about how that would get drawn. A tangent line skates along the edge of the circle. It does not cross through the circle. So if I put a dot right here as best I can with this pen, a tangent line would only touch that one spot. It skates along the circle. So if I did one like over here, it's going to intersect that one and only one point, and then it continues on its way. So it doesn't hit the circle more than once. That's a tangent line. Radius, we should know, is a segment with one endpoint at the center of your circle, the other one on the circle. So obviously we have a whole bunch of radii. This is just one of them. A diameter is a chord. We mentioned that earlier, but it's also a chord that's going to pass through the center of the circle. So here's our center. If I put one point up here, one point down here, I draw my chord in. So it's a chord because the two endpoints are on the circle, but it also passes through the center of your circle. Okay. Minor arc. So be careful with these minor arcs and major arcs. These would be things, if we were in class, that I would emphasize a little bit to make sure we understand the difference. An arc that is less than halfway around the circle. So first, when we talk about an arc, what we're talking about is the distance around our circle. That's an arc. So that's an arc. They can be small little arcs here. They could be in between. There's an arc, but it's basically the circle itself is when we're talking about our circle. So let me erase this. A minor arc is an arc that is less than halfway around the circle. So let's draw in a diameter, because a diameter cuts our circle in half. So any arc that is smaller than halfway, so this would be a minor arc. Down over here, this is a minor arc because it's less than halfway. If I do one more, do it in black. That's a minor arc because it's less than halfway around our circle. Okay? Versus a major arc. So now let me draw in the diameter again. Cuts our circle in half. So now a major arc is more than halfway around the circle. So now, like I had here, this red one started here and we just went to that distance. If I start the red one here, now it's got to go at least past the halfway mark. So now here. So this would be a major arc because it represents more than half of our circle. So minor is less than half, this guy. Major arc has to cover more than half of our circle. In between there is what you would have a semicircle. The semicircle is the arc that is exactly halfway around the circle. So if I start with that same diameter, a semicircle is the arc that goes halfway around. So it's not less than half, it's not greater than half, it is exactly half. All right, so that's our semicircle. Next one, a central angle. If you think about what central means, the center of our circle is right here. So it has to be an angle, so central angle, an angle whose vertex is the center of our circle. So if I now make an angle from right here, go out to my circle, go out to my circle, this angle that I just created is my central angle. The vertex, this guy, is the center of our circle. All right, so that's our central angle. An inscribed angle is an angle whose vertex is on the circle. So take a point, put it on the circle, and then make an angle from this point. So I'm going to extend it out to here, and then here. These can go further if you want. They don't have to stop at the circle. Same with this. This could go further if we want, but it just has to start at the beginning. But typically when we're dealing with circles, let me erase that. All right. That's what our inscribed angle is going to look like, because we just created an angle here and our vertex is on the circle. All right, then last but not least, intercepted arc, the portion of a circle that lies between two lines, rays, or segments that intersect a circle. So there are a lot of ways to get an intercepted arc. I'll kind of show you these three. It would lie between two lines or two rays or segments that intersect the circle. So let's say, if we drew in like a central angle here, that's our angle. The intercepted arc would be the arc that's created by that central angle. So this is an intercepted arc. If we drew in an inscribed angle, so let's say I drew an inscribed angle from here to here, the intercepted arc would be here. Okay? So that's our definitions. All you're going to do in this next page, I'm going to give you a diagram and then we're just going to go through labeling all of this. with these vocab words. So let's go ahead and do that. So we'll use this diagram, and it just says using that diagram name, basically what we just talked about, the words, definitions that would apply to these little explanations. So number one, it says name the center of the smaller circle. So we look at our smaller circle. All right, here is our center. We would just call that point A. All right, A is the center of our circle. If I ask you to name the center of the larger circle, so we look at our larger circle, we would see that A is also the center of the larger circle. And because both the smaller circle and the larger circle have the same center of A, number three is saying since both the smaller and larger circles share the same center, what word above that we would have done on the first page best describes the circles? They would be concentric, sorry. That's why I'm not an English major, I suppose. Concentric angles. All right. Number four, name a radius of the smaller circle. So there's a couple of here that we could write down, but the radius has to extend from the center out to the smaller circle. So one radius that we could name is AC. It is a segment, so we put the little segment symbol above it. We also could have done a D. That starts in the center and goes out to the circle. And we also could have done a B. The one's not working so good here. A, B. All right, that segment is also a radius of the smaller circle. Number five, if I wanted a radius for the larger circle, then we don't have a lot of options. There's really only one segment that starts at the center of the larger circle and extends out to the larger circle, and that would have been from A to I. So segment AI is the radius of the larger circle. 6, name a point in the interior region of the smaller circle. So let me again clear this up. So look at your smaller circle. The only point that we could say is actually on the inside of the smaller circle is point A. Name a point that is in the exterior region of both circles. So basically means outside of both circles would have to be point H. Okay. Now let me try and make this a little smaller. Okay, hopefully this will now fit. All right, 8, name a point that is in the exterior region of the smaller circle, so outside of the smaller circle, but still inside the larger circle. So we want to be outside the smaller circle, inside the larger circle, has to be point G. Okay. If we want a chord, let's see here. Name a chord. We have what looks like 2 chords. So a chord has to have the endpoints on the circle. So it's a segment whose endpoints are on the circle. So one of our chords would be from segment E to segment F. Both endpoints are on the circle, so EF is a chord. Segment EF. And then the only other chord, remember, a diameter is also a chord. So the other chord could go from B to C. Both endpoints are on the circle. It also is your diameter, but we could definitely still say that that is a chord. So B, I'm sorry, wrote that in the wrong spot. Although that's going to be our answer, I suppose. But a chord could also be said to be BC. And then 10, we kind of just did it. The diameter is also BC. Okay. 11, what is the length of the diameter of the smaller circle? So we talked about this if you watched yesterday's little video. The diameter goes from one end of the circle through the center, all right, all the way through the back. I'm sorry, we just talked about that today. We did circumference and area here coming up in a minute that you're going to see that we did yesterday. But if I just want the length of the diameter of the smaller circle, we did talk about that because we know the radius of the smaller one is 8. The diameter is always twice that long. So if that's 8, this is 8. Diameter has to be 16. Similar with the big circle. If we want the diameter of the big circle, the diameter or the radius of the big circle has to be from A to I, and you can see that we have 8 and 3 combined would give us 11, so that would tell us the other side would also have to be 11, giving us a diameter of the largest circle of 22. Okay. All right, so again, let me see if I can make this smaller without losing it. Yeah, that's what I was afraid of. Bigger. Okay, so 13, we can see all of this. So ED, when it says what kind of arc is ED? So let me create some space here. So if we look at arc ED, it runs from here to here. So that is arc ED. Yeah, put it all there. How many are there? So there are two ways that we can define this arc. If we go back, we have either a minor arc, which is less than half of the circle, or a major arc, which is more than half of our circle. So if we look at ED, and again, this is our little symbol for ED. I should share that. So if you see the little arc above it, all right, that's why we have that arc ED, has that little thing above it. So even if I didn't include this word, we would say, what is arc ED? Like, what kind of arc is ED? We would know that's an arc length. So we look at ED of that small circle, that's definitely smaller than half. So this we would call a minor arc. All right, let's go to the next one. Name a major arc. So number 14 is asking us to name a major arc. So again, major arc has to cover more than half of this. So now the important thing about a major arc, so let's find a major arc. We can go to any circle. So I'm going to use the smaller circle because we have enough info for this. Let's do the arc from D. Get the right thing here. So I'm going to go from D all the way around to B, because I think pretty obviously that's more than half of our circle. So the important thing with this, whoa, that's cool. So the important thing with this now is when you name a major arc, notice how this starts at D and then it ends at B. So let me get rid of those. What we can't do now, if I'm going to name a major arc, we have to be specific with this. If I just put DB, what that gives us is the smaller arc, DB here. So the way we name a minor arc is always with 2 letters. The way we name a major arc, we always want to name it with 3 letters. Sorry, my writing looks like chicken scratch. It's kind of hard to write with this pen. Oh, come on. So instead of calling this DB, because again, if I call this arc DB, it's going to give us this little smaller distance. We want a major arc, we're going to use 3 letters. So instead of calling it DB, we're going to call it D. And then notice how C and F are both in between. We want to pick either one of those. I'm going to pick C. We're going to go D, C, and then to B. We put the little arc symbol above it. All right, that's how we have to name a major arc. That tells us that we're going to go from D to C, and then we're going to go around to B so that we are going in this direction. Because if we just name 2 letters, we are naming this smaller one. Okay, so hopefully that makes some sense over the video, and you'll have some practice on that as we move along. But that's one thing to be careful of. All right, that's definitely something that I would make a big point of emphasis on if we were in school. All right, a couple more here. 15, name 2 semicircles. So we have 2 different semicircles. Kind of the same thing. Semicircle from B to C. Well, if we just use those 2 letters, how do we know which we're talking about, the top half or the bottom half? So to name a semicircle, we're going to have to do the same thing. We're definitely going to start with B. We're going to finish with C. And then we have to use one of the 2 points in between. So either E or D. We want to name this with 3 separate points. So I am going to pick B, E, and then our C for our semicircle. So we'll go, what was it? B, E, C. So we'll go B, C, and then that's an arc. All right. The other one would be the bottom half of our circle. So if we go from here to F to C, then we know we're including the bottom half by using the F. So we would call that B, F, C with the arc symbol over the top. 16, 17, this was yesterday's stuff, yesterday's homework, a little refresher here. What is the area of a smaller circle? Of the smaller circle, that's our area formula. So for this problem, if we went up to here, we can see that the radius of our small circle was 8. So if we want the area, it would be pi times 8 squared. So 64 pi. If we want the, oh crap, sorry. They wanted the larger circle. So let's try that again. We want the larger circle for this one. So we want the radius of the larger circle. So that's this guy. So the larger circle's radius is 11. So we would do pi times 11 squared, so 121 pi. Next one is the smaller circle, and that's just our circumference. So the circumference, here's our circumference formula, whichever one you prefer. The circumference of the smaller circle should be 2 times pi. I'm going to use this one. All right, I like the 2 pi r version. 2 pi times your radius. So if we look at our smaller circle now, like I did earlier, clean all this up now. The smaller radius is 8 from here to here. So plug that in, and we should get 16 pi as the circumference of our smaller circle. Okay, so hopefully not too bad. Just got to get those definitions down. It's pretty much all we were concerned about today. Tomorrow, so I have the assignment attached to the same message where you got the video. Go ahead and do that. Reference back to this if you need it. Ask me any questions, but that will get you through today, which is Tuesday, tomorrow, which will be Wednesday. So our next posting I will put on our next section will be on Thursday. So enjoy the rest of your day. Again, miss everybody. Hope to see everybody soon. Bye.